So today we're going to start talking about proportions, and today specifically solving proportions. If you need to look something up, this will be chapter 1, lesson 6, and we're actually going to do this over the course of several days. Today we're going to focus on what a proportion is and how to solve it. And then we'll get into how to set them up in the coming days. Proportions are huge in middle school and even into high school. We use them for percents. We use them for equivalent ratios and rates. We might even use them when we start talking about statistics at the end of the year. Okay. They're also fairly easy once you kind of get your head wrapped around them. They're very consistent and straightforward every time you do them. Okay. So what is a proportion? We've talked about are things proportional, and that was kind of a preview. A proportion is simply two equal ratios or two equal rates. It's going to look like this, like two equal fractions. Now, I gave this to you with just variables of A over B equals C over D, where B cannot equal 0 and D cannot equal 0, because you can't have 0 in the denominators. That's just a little thing we have to toss in there. If you notice, there are 4 positions or 4 spots in this proportion, 2 equal fractions or 2 equal ratios. Usually, you will be given 3 and you need to figure out the 4th. That missing number can go in any one of the 4 spots, but you're going to do it the same method, the same way. We're going to use something called cross products or cross multiplication. There is a situation, and I'll show you, I have an example that I'll show you, where you can almost treat these with equivalent fractions, which is how you've actually been doing proportions for a while. But with the equivalent fractions, that is one method. But when you get to something like 4 and 10, equivalent fractions aren't going to go so smoothly. Okay, so let's jump into this. My first proportion here is x over 4 equals 9 over 10. I don't really have there's nothing in common. I can't do that equivalent fractions thing. So let's do some cross multiplication. We're going to work with the diagonals. And I know it's going to look like an extra step. Please do it, at least until you wrap your head around this. Take the time to write out the steps that I'm going to show you. All right, so pick a diagonal. It doesn't really matter which one you start with. Let's say we pick that one. So that's going to be 10 times x, right? Because cross multiplication makes me think that I'm going to multiply. And then we're going to do the other diagonal. I'm doing these in colors for the first few, just so that you see what is coming from what. So 4 times 9 is 36. This has now made an equation. My pen wants to write. There we go. So I've come up with 10x equals 36. Well, you know how to solve those. We'll divide both sides by the coefficient, 10. 36 divided by 10, you can slide a decimal or grab out your calculator, but this will give me 3.6. So in this place, we would get 3.6. Now, I'm going to rewrite it because I want you to see something. So 3.6 over 4 equals 9 over 10. If you remember back to, is this proportional or is this not proportional? We said that things have to be the same. The relationship has to be the same. So if I look at my original relationship that I knew 9 over 10, they're pretty close together. That fraction or that relationship is most of whatever you're talking about. So let's look at 3.6 and 4. They're pretty close together. That's most of whatever it is we're talking about. That feels like a reasonable answer, 3.6, right? If I can take a second. If I had gotten something like 8 over 4 equals 9 over 10, that doesn't feel right at all. First of all, the left is an improper fraction. The right is not. These are close. This is like, no, that's just not right at all. And if I had gotten, say, 1/4 equals 9/10, this is almost all, and this is hardly any of it. Okay, so you should kind of stick with your gut on, is it the same? You might not have an exact mathematical answer, but when the number's wrong, you should be able to be like, something doesn't seem right there. Okay, let's go to our second example. Should probably section these off. There we go. Okay, so I have 2 over 34 equals 5 over y. If you noticed, our variable switched. It's in a different position. Doesn't make a difference. We're still going to do our cross multiply. I'm going to live on the edge, and I'm going to go the other direction first. So let's do 34 times 5. Sometimes, if you're waiting to pull out the calculator, sometimes people will actually write 34 times 5 equals 2 times y. Sometimes they'll just multiply it and give the answer. It's totally up to you, however you choose to do it. Okay. If you are a lover of office products and colored pens, feel free to circle and write in colors. It is definitely helpful when you're learning. So we're going to do 34 times 5, and I get 170. And then we're going to go the other diagonal and get 2 times y. So now I have 170 equals 2 times y. What if I had done the 2y first and I had gotten 2y equals 170? Does not make a difference, because in both cases you're going to divide by 2. You'll get y by itself, and then you know it doesn't matter which side of the equal sign that y is on. So let's do that. Divide by 2, divide by 2. You get 85. So y equals 85, or 85 equals y. That is my answer. I would encourage you to circle it. It doesn't get lost in all this beautiful math work. Okay. If you want to see this, and in the beginning you might choose to rewrite this just so that you can kind of get a feel of what's going on. 2 out of 34 is 5 out of 85. That doesn't feel bad. This is a very small number and a pretty big number. Still a pretty small number and a pretty big number. We can also compare side to side. This more than doubles, and so does this. Okay? It's just a little bit more than double. It's not like we went crazy and multiplied by like 400. All right? So kind of use those things to get a gut sense of what's going on here. Example 3, again, our variable moved. So 7 times 21 is going to give me, that would be 147. And then 3 times n, the color that I'm using makes absolutely no difference. It's really whatever I'm grabbing out of my hand. Okay, so 147 equals 3n. We'll divide both sides by 3. 147 divided by 3, 49. So n equals 49. Now, this is a case that I could have used equivalent fractions to solve, because 3 and 21 will play nicely together. So I could have done 3 times 7 and get 21, and then do 7 times 7 and get 49, the same answer. Here we've got an improper fraction. If I was to put the 49 in place of the n, I would still have an improper fraction. So I've got lots of ways of checking myself to make sure that what I'm doing is on the right path, right? All right, last one for the example. So we've done an example now with the variable in each of the positions by the time we're done here, all right? So let's do x times 5, or 5x. Oops. Let's do 41 times 2, the cross products they're called. So that's 82. And then I'm going to have to get x by itself. So to do that, I'm going to divide by 5. This one's not going to come out evenly. And I got 16.4. So x equals 16.4. Double check. This would be improper. If I put the 16 here, this would also be improper. So we're good. Now, there is a shortcut that you don't have to go through and write all these equations, but I'm not going to show you today, because I really want you to practice this. I want you to have good habits, and then once you're in good habits and you have a really solid understanding of what's going on, then I can show you the shortcut. Okay, so once it's set up, you're going to pick your diagonals and just multiply, set up your equation, and then divide so that you get your variable by itself.